video we are going to discuss about the application of the derivative, and here we have to discuss about the increasing function, decreasing function, and the maxima and minima. Now what do you mean by increasing function? The definition goes like this: a function fx defined on an open interval I is said to be increasing if any two values x1 and x2 taken from the interval I in such a way that if x1 is less than x2, so defined in such a way that if x1 is less than x2, then the fx1 is less than or equal to fx2, then the function is said to be increasing. Means if you have, suppose if I represent it graphically, then it will go like this. Suppose I have a value x1 here and x2 here, and my graph goes like this. So the corresponding to this point x1, this is my fx1, and corresponding to this point x2, this point is fx2. So we know that when we are going up on the y-axis, this is our origin. So on the right hand side, when you are going, so it means x1 is lesser than x2, because when you go, this is an increasing line. So every point here is greater than the point on its left and smaller than the point on its right. So x1 is lesser than x2 and x2 is greater than x1. Same way, if any point is above the point, like fx2 is, this value is greater than this value, that is fx1. So same thing, if you see fx1 is less than, this value is less than this value if x1 is less than x2. Now just take to explain this idea, I take a simple function and try to prove that. Prove that fx is 3x plus 2 as the increasing function. Is it increasing? So the answer is that I'll say that let x1 is less than x2. Okay, then you multiply 3 on both sides, so you get 3x1 less than 3x2. Then you add 2 on both sides, so 3x1 plus 2 less than 3x2 plus 2. Now see, what is 3x1 plus 2? If you put the value of x as x1, this 3x plus 2 will become this. So this is your fx1 and this is your fx2. This is less. If there is only less than sign, then it is called strictly increasing. So strictly increasing, and if there is equal to sign, you can say just increasing. So the definition goes like this: if fx defined on an open interval I said to be increasing if x1, x2, any two elements taken from the interval I, so that if x1 is less than x2, then the value of the function is less than or equal to the value of this another function. This is the definition. Same thing we can say that for decreasing function also. Now we have to use application of derivative, and then the theorem says that function is increasing in an open interval if f dash x is greater than 0. Means if derivative of a function is greater than or equal to 0, means positive, greater than 0 is positive and greater than or equal to means 0 and positive, then the function is increasing. If it is only greater than 0, this is strictly increasing, and if it is greater than or equal to 0, then you can say it is just increasing. So now we'll use the idea of differentiation to find out the solutions, find out the range where the function is increasing or decreasing. Okay, so now let me think, let's clear the screen and we'll discuss about the decreasing function also. Okay, now for decreasing function, we have the same definition. Instead of this increasing, we will be writing decreasing. And x1 is less than x2, but this one will become fx1 is greater than fx2, and the graph which is going like this in the previous question, it will become something like this. Means at this point x1, this is the value of the fx1, and when it is this point x2, then the value of the function is fx2. So you see x1 is increasing from x1 to x2, but the value of the function is decreasing. So this is a decreasing function. Now definition goes like this, and in terms of derivative, if it will be something like this: if f dash x is less than 0, it is called decreasing function. Decreasing function. Okay, now I mix these two and I draw the graph. First let me clear this graph. Okay, now I just draw a graph. So this line should be a little darker. Okay, now I have a graph and I just draw a random graph like this. Okay, so now see, from here, like see, if I say that this value is small a and this value is small b, this value is small c here. So this value means if I say this is a, so the corresponding coordinate here will be fa. If this is b, so this is your fb. If this is c, then here you get your fc. Now if you see the graph, then you can see that between the interval a to b, like this a to b interval, a to b, this part, the graph is strictly increasing. Now from here, means from the point b to this point c, the graph is strictly decreasing. From the point c to say this point is d, so this coordinate is d and fd. So again from here to here, the graph is increasing. Now, so when we find slope, so you know that the slope is the tangent. So if this is my slope, so here the slope is like this, here the slope is like this. So slope is always making acute angle with the graph. Now here you see, and you know that the tan theta is slope, so m equal to tan theta, and the theta is the angle that the tangent line makes with the positive direction of x-axis. So here it is just to touch a line and touch it at every point on the curve. So here you see, look at the same sort of direction, it is making an acute angle with the positive direction of x-axis. Here also it is acute. I keep on going acute, acute, acute. Now the graph is becoming parallel, this line is becoming parallel at the peak. So at this point the tangent is 0. Now if I say the tangent is becoming, or the angle is becoming obtuse, and the tan value in the second quadrant will become negative. So now this is negative, negative, negative. Again it is 0, and then from here it is again start increasing like this, and then again it peak, it becomes 0. We have seen that by definition it says that if f dash x is greater than 0, then the value, the function in that range will be called as increasing function. So this is for increasing. Means if the slope or the derivative is positive, it is increasing function in that domain, and if it is f dash x less than 0, it is decreasing. And what if it is equal to 0, means at this point? What about this, where f dash x is 0? These values are called the stationary point f dash x equal to 0, where either the f dash x is 0 or f dash x does not exist. These are called critical value or stationary points. Stationary points means we cannot say anything about that. Now I'll take some example to solve and explain you this idea. This is all theoretical understanding about the function, the increasing functions, intervals and the tangent. Now how will we apply them? But every time again I want to make it clear that whenever we are finding the slope of a function, when we are finding the derivative of a function, we are exactly finding the slope of a function. And what is the slope? Slope is the line which touches the curve at a point, and that is, you can say that is exactly the value of the tan theta, means the angle of inclination fed into the tan theta. This theta is the angle that the line makes with the positive direction of x-axis, and the tan theta in the first quadrant it is positive for acute angles, and in the second quadrant it is negative. That's why in the second quadrant, when the theta changes from the 90 to 180, it becomes negative. Same way the differentiation in those ranges will also become negative. Now let me have some questions. So now I take one function, that is fx equal to x square minus x plus 1, and we will be discussing its nature, whether it is increasing, decreasing, or strictly increasing, strictly decreasing in the interval 0, 1. So first you have to find f dash x. F dash x is 2x minus 1. Then you see that if it is strictly increasing, then f dash x should be greater than 0. So 2x minus 1 is greater than 0, then x is greater than half. Okay, when I see for f dash x less than 0 for decreasing function, then I'll have 2x minus 1 less than 0. So x less than half. Means what does the graph suggest? That for x greater than 2, the function is strictly increasing, and for x greater than half, this is strictly increasing, and for x less than half, it is strictly decreasing. Means that if you have the open interval, we have the open interval from 0 to 1, there is a critical value half, because if you see, if I just try to set that f dash x is 0, so to find out the critical value, if I set f dash x is 0, then I'll find x equal to half. So x equal to half is a point where the differentiation of that function is 0, means this is 1. Now before that, you see that between 0 and half means when x value is less than half, it is decreasing. So here the graph is decreasing, so it may have the nature something like that. And from the half, it is not exact, we are just suggesting it is that x greater than half, then it may have something like this. So it means between interval 0 and 1, it is neither strictly increasing nor strictly decreasing, because it behaves that from here, from just after 0, in the open interval 0 and half. Open intervals are like if a and b are the open interval, the end points are not included. It means that the a should be greater than, and like this. This is not equal to. And the closed intervals are like this: a, b. It means a less than or equal to x less than or equal to b. So between 0 and half, the function is strictly decreasing here because x less than 2, and between half and 1, in this zone, it is strictly increasing. So for the full interval 0 and 1, it is neither strictly increasing nor strictly decreasing. You can take the whole thing in a very such a way that when you find f dash x and you set it to 0, you find a critical value. So critical value is half. Now we were given the domain 0 and 1. So now this critical value divides the domain into two smaller domains. One is from 0 to half and other is from half to 1. And when you analyze that, in one interval 0 to half it is behaving differently, and in another interval it is half and 1 it is behaving differently. So now I take another example just to explain the idea in a more clearer way. So now here I have taken another function, that is fx is x cube minus 6x square plus 12x minus 18, and whether we have to find whether in this whole domain of real line, whether this function is strictly increasing or strictly decreasing, whatever what it is. So first rule says that we have to find, first step is that you find fx, that is 3x square minus 12x plus 12. So you see that you can take 3 common, this is x square minus 4x plus 4, that is 3x minus 2 whole square. Now f dash x. So here you see that we have a critical value, that is r, like when f dash x equal to 0, there x is actually 2. So the 2 is the critical value. This is the whole real line, you can say. This is whole real line. Now this has divided that what is the value of this f dash x after this 2. So you see that if you take any positive number, then like suppose if I take 5, so 5 minus 2 whole square is positive. So here also it is positive, here it is also it is positive. Like suppose if I take a number minus 3, so minus 3 minus 2, because the square is even number. So x minus 2 can be either 0, this point, positive squared, positive, negative squared is also positive. It means f dash x is greater than or equal to 0. It means this function is just increasing function in the whole interval. Okay, so this is the idea. Suppose I make some changes into this to make it whether it is strictly increasing. So what can I do that? I can make this 12 as 16x. So this will become 16. And then I will have this whole thing, 3 4s are 12 plus 4 is still left. So this will become 3x square plus 4, and then you will find that you will not have this critical value anywhere, because this one will always be greater than 0. So in this condition we can say that this is strictly increasing. Got it? So this is strictly increasing when you have 3x minus 2 whole square, because this quantity is always positive. Whether it is this quantity can be positive when x is greater than 2, can be positive when x is less than 2, and can be 0 when at 2. But when you adding 4 to this, it means it will be positive all the time in whole domain of real line. So you can say f dash x is greater than 0, and it means it is strictly increasing. Strictly increasing. So this is all in this video, and the next video will discuss something more about some other important features of the maxima and minima.